We're going to go through 6.1, which is exponents. I'm going to just go through my slides for my PowerPoint, and my advice is for you to just follow along on your problems that I sent you to print off, and you can do those with me. All right, so the first thing we're going to do is simplify expressions by using properties of integer notations. We're going to recognize which property of exponents is used to simplify an expression. So one of the first things I want to do is show you how to use your calculator. So this is the calculator I wanted you guys to get. If you have this one, then I'm going to give you some specific directions. If not, you'll have to find a button that's comparable on your own calculator. All right, so one of the first buttons I'm going to talk about is this button right here. It's called a caret button. So for the first problem, I see 6 to the third power, which is the same thing as saying 6 times 6 times 6. So if you don't have a caret button, you can always just multiply that in your calculator, 6 times 6 times 6. Or if you have one of these, you're going to type in 6. You're going to hit your caret button, and your exponent is 3. So can you guys see that? 6 to the third. There we go. That's what your calculator should look like. And once again, we're using this button, which is the caret button. Okay, so you just type it directly into your calculator. And when we hit enter, there we go. Hit enter, our answer is 216. So 6 to the third power is 216. This is the same as multiplying 6 times 6 times 6. Anytime you have a number or a variable raised to an exponent bigger than 1, this is called the base. So the base is 6, the exponent is 3. Now letter B, you want to make sure you type this into your calculator exactly like you see it, including the parenthesis. If you don't put the parenthesis in correctly, you're going to get the wrong answer. So on this one, I'm going to use my parenthesis. I'm going to use my negative. This is the negative. This is a minus sign. This is a negative. So make sure you type in -3 and your parenthesis. And either I can use my caret button raised to the second power, or if you see this x squared, that's how you always square a number. So I'm just going to hit x squared. And my answer is +9. Now, if I did not use my parenthesis, my calculator would have told me the answer is -9. So if I just typed in -3 without the parentheses squared, you notice the calculator tells me the answer is -9. Because without the parentheses, it's thinking, if I don't type it in with the parentheses, my calculator is thinking, what is the opposite of 3 squared? And that is -9. So that's why using those parentheses are so important. Oh, well then that leads us to letter C. So letter C, we're going to type it in without the parentheses. -3 raised to the second power is -9. So even though it looks like those two, letter B and letter C, would give you the same answer, you see that it doesn't. Letter D, we're going to use our parentheses. We're going to type in -7. We're going to use our caret button, raised to the fourth power, and the answer is 2,401. Letter E, we can type that in exactly like we see it. So if we weren't going to use our calculator for a second, we know that 3 times 3 is 9, and 2 times 9 is 18. Or, just so we're always triple sure, we're going to just type it in 2 times 3 squared, exactly like I see it, is equal to 18. Now letter F, we're going to talk about a number raised to the 0 power in a few minutes, but basically any number raised to the 0 power is always 1. But if I didn't know that, just like always, I can use my calculator. 5 raised to the 0 power Now when you're up there, if you notice in my calculator screen, you have to make sure you right click to get that cursor from up here in the exponent down. So I typed 5 to the 0 power. The rest of my problem was plus. And then let me make my screen. There we go. Plus, in parentheses, I'm going to do -3. Use my caret button to the third. And my answer is -26. And it's because -3 times -3 times -3 is -27. Any number raised to the 0 power is 1. So 1 plus -27 is -26. All right. So now that we've practiced in our calculator, we're going to look at a product rule. Now, the very first page of your notes is basically all of the exponent rules we'll be talking about. So I sent that to you so you could print it, you could keep it, you could look at the examples. But basically, the first thing we're going to start off with is the product rule. So that tells you when you have two numbers that have the same base, so a base is any variable or number raised to an exponent other than 1. So if you have two numbers with the same base and they're going to be multiplied, the rule is that you add those two exponents. So a to the m times a to the n is equal to a to the m plus n. So we're going to look at some real examples of that. Now you have another note here that if you have either a number or a variable and there's not an exponent, then we know that that is raised to an exponent of 1. So basically 7, only one 7 is equal to 7. So y is equal to y to the first. 7 is the same thing as saying 7 to the first. A is the same thing as saying a to the first. And that's going to come in handy when we're doing the product rule. All right, so on example 1 for letter A, we have two numbers that have the same base of x. Since the bases are the same, we're going to add the exponents together. So x squared times x to the 4th is x to the 6th, because we're just adding 2 plus 4. Here, I see y times y to the 6th. Now that's what I was saying earlier. It's important to remember there's actually a 1 beside that y that we can't see. So when we add 1 plus 6, the final answer is y to the 7th. Now this works also when you're not just working with variables, but you're working with digits as well. So I have 4 squared times 4 to the 1st. Well, since my bases are the same, I'm not multiplying my bases. I keep the base, and my answer is 4 to the 3rd, because 2 plus 1 is 3. Letter D, I have the same base, so my base is 2. I have 2 to the 3rd power times 2 squared, so 3 plus 2 is 5, so my answer is 2 to the 5th. Now I can continue on and simplify these because I could type this right here in my calculator. 4 to the 3rd power is just like saying 4 times 4 times 4, which is, I was about to say 64, but I better check it. 4 to the 3rd power is, yeah, it is 64. 64. A to the 5th, or not a to the 5th, but 2 to the 5th. So I'm going to type 2, use my caret button, to the 5th. My answer is 32. Now, obviously, if I have variables, this is as far as I could go, but for these numbers, I can literally simplify them and get a whole number. Letter E, I have -2 is my base. They're being multiplied, that's what the parentheses mean. 4 plus 3 is 7. So in my calculator, I'm going to put -2. Whoops. Oh my goodness. -2 to the 7th, raised to the 7th, is equal to -128. negative 128. All right, so now we're going to get to some problems that have coefficients. Now, if you look right here, y are the bases because y is being raised to the power of 2, and this y is being raised to the power of 9. But both of those bases are being multiplied by a number, and those numbers are now coefficients. These numbers in the front don't have exponents, so now they're coefficients. So on this one, we're literally going to multiply 2 times 3, and we get 6. And now our two bases that are being multiplied are y's. They're raised to the exponents of 2 and 9. So 9 plus 2 is 11. So I have simplified that expression. All right, same thing with letter B. Those two numbers in the front are both exponents. They're both coefficients. So we're going to multiply negative 3 times negative 4. We get positive 12. And then our base is x being raised to the power of 3. This one's to the power of 3, so 3 plus 3 is 6. And then letter C, we're going to multiply our coefficients. Negative 6 times 8 is negative 48. The base of A and A, they're both being raised to the first power, so 1 plus 1 is 2. And then for the base of B, we have a 2 and a 3, and we get a 5. So recognize that even though I don't see anything next to the A's, that means that the base A both have an exponent of 1, and the rule still applies. If I'm multiplying two numbers that have the same base, I add the exponents. All right, so that takes us to our next rule. The rule is any variable or number that's raised to the 0 power is 1. And that may not make sense, but let me just show you a quick example of why that does make sense. So in math, we have to always see a pattern. So 5 squared is 25, because that means 5 times 5. Well, 5 raised to the first power is 5. So this number, 5, is 1/5 of 25. Well, if we go on with the pattern, the rule that I told you, any number raised to the 0 power is 1. Then if this is 1/5 of 25, then this number has to also be 1/5 of 5, and it is. 1 is 1/5 of 5. And if that's true, going on with our pattern, our next number would be 1/5 of the previous number. So 5 to the negative first is 1/5, which is 1/5 of 1. So anyway, I'll get back to explaining this in a few minutes, but I just wanted you to see that the pattern with exponents have to be consistent, and that's why any number raised to the 0 power is the number 1. So how that looks in some examples, look at letter A. 10 raised to the 0 power is 1. Letter B, x raised to the 0 power is 1. And 1 times anything is what we're multiplying by. So the answer is x to the 3rd. Well, if you don't like that, we could also use our product rule, where it says two numbers that have the same base. You would add their exponents. Well, isn't 0 plus 3, 3? So basically, we got what we wrote by either using our product rule by adding our exponents, or if we consider that this is the number 1, and 1 times anything is the anything part. All right, letter C, this number, which is a negative number raised to the 0 power, is equal to 1, because that's a rule. Anything raised to the 0 power is 1. All right, moving on. So now we have another rule. If you are dividing two numbers that have the same base, what you do is you subtract their exponents. So a to the m divided by a to the n is equal to a to the m minus n. So let's look at how that plays out. So in example 4, we have letter A, we have x is raised to the 6th power divided by x. Well, if we don't see an exponent, what is it? It's a 1. So the rule says we're going to subtract the exponents. Well, 6 minus 1 is 5. All right, letter B is y to the 8th divided by y to the 2nd power. The rule tells us that we're going to subtract the exponents. So the answer is y to the 6th. And then letter C, 2 minus 2 is 0. X to the 0 power is 1. All right, so let me show you a different way to look at this. So basically, letter A, well, I have more space for letter B. If I wrote this out, what it means is 8 y's. Y to the 8th is the same thing as 1, 2, 3, 4, 5, 6, 7, 8 y's being multiplied, divided by y times y. Well, you can always simplify on top and bottom, so those two go away, these two go away, and what would we be left with? We would be left with 1, 2, 3, 4, 5, 6 y's on the top, and so our answer would be y to the 6th over 1, which is just y to the 6th. Letter C, we could show it the same way. We could show x times x on the top divided by 2 x's on the bottom. Well, if everything cancels out, aren't we left with 1? We're not left with 0 because it's a division problem. We're left with 1, which is what we got here. All right, so then, of course, they have to get a little bit more complicated. So letter A, on example 5, we have 2 coefficients of 15 and 3. So we can literally divide 15 by 3. So even if that was just a fraction by itself, 15 over 3 simplifies to 5. Divide them both by 3, I get 5 in the numerator. Now, in the numerator, we also have 15 x's. I could write those out, but that'd be a lot of x's. I'd have 3 x's on the bottom. I would have 3 pairs on top and bottom that cancel. And then wouldn't we have 12 x's left on the top? In other words, 15 minus 3 is 12. And that's our simplified answer. All right, letter B, we're going to divide our coefficients. 20 divided by 2 is 10. We'd have 10 x's on the top, 2 x's on the bottom. We'd have 2 pairs of x's that cancel, and we'd be left with 8 x's. Here we'd have 6 y's across the top, 3 y's on the bottom. 3 pairs would cancel out, and we would have 3 y's left on the top. All right, so now we're going to see that sometimes we end up with the negative exponents. So basically, anytime you have a negative exponent, you take whichever, if this is on the top, so if I wrote 5 to anything, whether it's a positive exponent or a negative exponent, we can all agree that that is sitting in our numerator position, right? Any whole numbers or any variables can be written over 1 always. So basically, if we have a negative exponent, whichever side of this line it's on, so here it's on the top, I could write something like this, where my negative exponent would be in the denominator. In order to make it a positive exponent, you're going to flip it from wherever it starts. So this starts in the numerator, a over 1. To make that a positive exponent, you drop it down to the denominator. So 5 to the negative 2nd, it's in the numerator right now. I'm going to drop it down to the denominator, and my negative sign goes away. Here, it's already a positive, so this is already simplified. 5 squared is just 25, and that would be my final answer. Now on this one, I have 1 over 3 to the negative 2nd. Well, 3 is in the denominator. In order to make that 2 a positive, I'm going to flip this whole thing up to the numerator. I don't have to write over 1. And so my final answer would be 3 squared, or 9. So there's a saying in math: if you have a negative exponent, if you flip it over the line, you change the sign. Flip it over the line, this line right here, and change the sign. I had a negative exponent here. I flipped it over the line. It went into the numerator. Change the sign. So anytime you have a negative exponent, if you flip it over the division line or the fraction line, you're going to change the sign.